Hello, everyone, and welcome to our last article that touches on the ISTE standards, and in this case, communicating science creatively. And so, as a reminder, we've covered all of the ISTE standards, and if you go to ISTE.org/standards, you can see all of these different standards that represent here. And we've talked about in the past how knowledge constructor and innovative designer and computational thinker represent the identities students should take on as they become productive 21st century citizens and workers. This month, we're focusing on the creative communicator. This is where students will communicate clearly and express themselves creatively for a variety of purposes and using a variety of platforms. So, as we think about what this might look like, and you go down and you delve into what the performance indicators will tell us, things like remix are words that will sort of pop to the surface. And this is a relatively new term about the use, an idea of taking things and bringing them about in a different way. And so the idea of remix, and if you want more information, I would urge you to go to Creative Commons. They have lots of information and they have lots of media that you can use. So the idea is that you would be able to take this material, it's licensed openly, that you would be able to repurpose it for your own purpose, and then you would share it back out so that others can see your work. Now, as a simple way to get kids thinking about like this idea that's related in here, the idea of remix. Like if a student were doing a project on snakes, they might just do a Google search, and if they wanted pictures for their project, they might say, okay, well, I'll just do the image search, and they would grab these photos. But some of these photos are not able to be taken, and so you can click on tools, and I will point out Google changes these things a lot, but for now, under tools, there's usage rates. And so you can see like labeled for reuse, labeled for non-commercial reuse with modification. And when I click on that, I do get a different set of images, but the help that Google has given me is that now I know which types of images could be used and modified for my purposes. So we want to get students thinking about how to do those types of activities. Now, as we go back, what I really want to focus on is getting students to be able to express themselves in a variety of different ways. So if we jump back over here to Word, one of the ways that students can work through their projects is just through typing things up, but including their scientific formulas, including pictures and having them labeled, to taking their graphs and embedding these. And whether you're using Google Docs or anything like that, this has become so easy that it should be an expectation. And when we talk about students presenting their evidence and citing their evidence, this is the type of work that we want. And so as students, if they do a Boyle's Law Lab with a simple syringe, there's no reason why they really shouldn't have their own picture that they've created. So in this case, this is their graph, this is their syringe, this is their graph that they've completed using something like a gizmo online. And so they're taking screenshots, but they're creating their own media through this project. And we mentioned in the article that the sign that would hang in our classroom was UCC, which standard for user created content. Now, another way that students can express themselves, you can see like here's an infographic that they've made. And a lot of the arrows they have made themselves. In some cases, you will have to go get tools. And so you can see that they're citing where those tools are gotten from. But the rest of the images are from themselves. But the key idea here is that students are communicating information. So in this case, there are different ways that you might need to add vectors, and the students are putting these directions out for themselves or for others so that we get later in the year, they should be able to go back and follow these. We think about concept maps all the time, but concept maps can be used for note taking that might organize us in creating our own pictures of things and citing that information as we move along. And so those are just a couple of examples that I wanted to share with you. But when we think about this, really, there's a whole sense of media that can be done. And there's the idea that we've talked about being vague with your instruction. Well, when students have the opportunity to to do things. Like this was a wave project where I didn't tell students, I want you to make a dance, a song, or whatever. I just said, I want you to communicate to me what waves do. Well, this student made haikus, and I would play the audio. You would be able to hear him read his haikus. I thought this was a fantastic way for a student to communicate the ways that waves actually, or the things that waves actually do. And so when we talk about communication, this is exactly the type of work that we want. And there are all kinds of tools that students can use for this. So I had students, they did a project with Story Jumper, where they did their projectile launcher lab. And so the students are, using the pirate theme, but this would be an interesting way for them to go through and tell their story. As I just flip through this, they have their calculations in here, as you can see, as a part of the story. And so there are all kinds of tools. You just have to be a little bit creative in terms of how you want to do these things. So I have had students, they've used like PowerPoint, and they've used that as like a storyline, right? So this is based off of Catcher in the Rye, but it's Catcher in the Waves, and so these students told a story. I also get all kinds of videos. Like here's one where students are using um, little statues that were in my classroom, and other signs that they made as they talk about relativity. I've gotten things from Powtoon. So this was an interesting video here. If we take a look real quick, I'll scrub through. So they're just using the tools within Powtoon. Now this is a classic lab in physics where the students used, they had two carts that would collide, and the carts had magnets, and then they would bounce off each other, and they had to do conservation of momentum for this lab. So they're setting it up, and they found that there were magnet tools in there, so they were able to use those to represent the motion sensors. They have these video cameras back there. I thought it was a very creative way, and they've explained what they've done. And when we talk about to students about what a lab might look like, a lab summary, it's what did you do, what did you find out, and how do you know what you found out? So in this case, they've now taken their graphs that they made, and they've embedded them. But not only that, but they draw attention to the specific places that they want information to be found by using arrows and markup of that. And within this, they even have a little bit of humor, right, as the guy hits himself with a stick because he's crunching the data. So when we think about like what those types of activities may look like, it really gets to the heart of being a creative communicator. By picking the source of your, or the tool that you're going to use, it really causes you to be in the evaluation stage. And the last thing I would just mention is that at the bottom, students publish their work. Okay, well, a great way to have students do that is to actually publish it for others to be able to purchase. And you can see things like Lulu, where you can create, publish, and sell your own book for free. Now, others will pay for it, and you can set your own prices, but this becomes a way that you can do fundraising or get parents involved. But students, I find, will do their best work when they have these opportunities to work through and get their work out to the community at large. So that's going to wrap up our work on the ISTE standards. Hopefully, we'll be able to delve a little bit deeper into how these standards can touch on the next generation science standards as we move forward.